When I was growing up, we were taught that there were 9 planets in our solar system. While this number has since dropped to 8, this does not diminish just how cool the former 9th planet is. In fact, I would wager that it is an even more interesting world to us now, despite it being classified differently. This is Cup of Science Joe, and today I am here to talk about Pluto, covering everything from its discovery to what we have learned from and about it. Now, speaking of its discovery, this happened in the year 1930 by an astronomer named Clyde Tombaugh. At the time of its discovery, Clyde was working at the Lowell Observatory in Flagstaff, Arizona. He made this discovery using what I like to think of as an early form of astrophotography. He would take images of the patch of sky where Pluto was thought to be, and these images were exposed onto large plates. Clyde could then load 2 of these plates into a device called a blink comparator. This would let him quickly swap between the 2 loaded plates and look for any movement or differences between them. And when he discovered the small dot of Pluto moving consistently against the background stars, he knew he had discovered something. After this discovery was made and confirmed, and the observatory released it to be checked on by other people, they started getting name suggestions from people around the world. The name that they selected came from an 11-year-old girl named Venetia Burney, who selected the name based off of the Roman god of the underworld. And as of this time, our solar system had gained its 9th planet, Pluto. But, as I hinted at earlier, this classification would not last forever. But we will get into that one later. For now, let's talk a bit about Pluto itself. It is rather small in size, having a radius of 715 miles, making it about 1/6 the width of Earth. For another point of comparison, our moon is around 1,079 miles. So the moon is bigger than Pluto. It has a larger radius, and it has roughly 6 times more mass as well. Pluto is also very far away from us and from the Sun. It is on average 39 astronomical units away from the Sun, or around 3.7 billion miles. Reaching it would be like driving around the Earth roughly 148,000 times. It even takes light 5.5 hours to make this trip, and it is moving rather quickly. This distance means that the sun is dark there, but it's not as dark as our night. If you were to stand on Pluto at noon and look towards the sun, it would be about 300 times as bright as our full moon. There is a moment each day near sunset here on Earth where the light is the same as it would be if you were looking at the sun midday on Pluto. Now for me, it's around 7:57 p.m. But if you're curious to find your Pluto time, there's a NASA link that brings you to this page here. I'll leave it in the description. And you basically come down and provide it with your location. And this will tell you roughly what time of day for you on Earth is the light going to match what Pluto would be receiving at about noon or midday for it. Pluto has an unusual orbit around the Sun when compared to the planets. It is both elliptical and it is tilted. The time it takes it to orbit around the Sun is 248 years. During this long oval-shaped orbit, it can be as far away as 49.3 astronomical units, or as close as 30 astronomical units from the Sun. An interesting thing this causes is that during its perihelion, which is when it's the closest to the sun, it is closer than Neptune. So it's inside of Neptune's orbit during that point. For its rotation, 1 day on Pluto takes 153 hours. Its axis of rotation is tilted by 57 degrees with respect to its plane of orbit around the sun. This means it's almost spinning on its side. And, like Venus and Uranus, it exhibits a retrograde rotation. This means it is spinning from east to west as opposed to west to east, like, say, the Earth does. Pluto's also got some moons, 5 to be exact. They are Charon, Nix, Hydra, Kerberos, and Styx. This moon system may have formed by a collision of Pluto and another similar-sized object in the past during the formation of the solar system. The most notable moon of these is Charon. It is by far the biggest of Pluto's moons, coming in at about half the size of Pluto itself. It is very close to it as well, orbiting at only 12,200 miles away, so they're like about to be kissing. Because of how close they are to each other, and how close they are in size, Pluto and Charon are tidally locked to each other, only ever showing the other the same side, as if in an endless waltz. And as far as I know, that's the only planetary system where the main body and one of its moons are both tidally locked to each other, at least in our solar system. For the longest time, we did not know anything about what Pluto looked like. It remained a speck until we got our first images from Hubble in 1994, which still did not reveal much aside a gray sphere with some surface details. It would not be until 2015, with the flyby of New Horizons, that we would get a true look at the beauty of Pluto. For now, though, let's turn our attention to 2006, when Pluto was reclassified as a dwarf planet. This happened for a couple of reasons. One is that we discovered another astronomical body called Eris that had traits very similar to Pluto, more similar to Pluto than either of them were to the other 8 planets. And so, unless we were just going to start expanding the number of planets in the solar system, this meant that new criteria needed to be set. There were 3 criteria selected for this. It is in orbit around the sun. It has sufficient mass to be rounded by its own gravity. And it has cleared the neighborhood around its orbit. Pluto clears the first 2 criteria. But because it shares its orbit with the rest of the Kuiper Belt objects, it does not pass the 3rd criteria. And so, it, along with other known objects that are similar, such as Eris, were then classified as dwarf planets instead. There's I think 5 or 6 dwarf planets now. Another one is Ceres. But the 3 examples I'll have here are Pluto, Ceres, and Eris. You know what, though? This does not mean Pluto is any less of a majestic world, regardless of our classification of it. And as I mentioned earlier, with the flyby of the New Horizons spacecraft, we really learned and got a visual of this. This flyby showed us that Pluto has mountains, valleys, plains, and craters. Its tallest mountains are between 6,500 and 9,800 feet tall, and are made of big blocks of water ice, which are sometimes coated with frozen gases such as methane. The large troughs and valleys found on Pluto can be as long as 370 miles. And to add more to the interesting features of this faraway dwarf planet, my favorite thing is called Sputnik Planintia, which is a large, partially glaciated basin that has formed into part of the heart-shaped topography that we've called Tombaugh Regio. You may also notice a red coating on a good part of Pluto. This is caused by what we call tholins. Tholins are a wide variety of organic compounds which are formed when carbons are struck by solar ultraviolet or cosmic radiation. And if we look here at Pluto and Charon, we can see that some of these tholins have escaped Pluto's gravity and fallen onto Charon. And because these two are tidally locked, the tholins always fall roughly onto the same spot. Now, there is surely even more that we know about Pluto and have discovered that I have not covered in this video, which only goes to show the takeaway that I would like to end on, which is regardless of what we as humans may classify something as, many of the astronomical objects out there are still beautiful, awe-inspiring, and have the ability to teach us even more about our solar system and maybe even our universe. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.